Hello students, hope you are doing well. Welcome to my channel where we nurture and learn mathematics beyond boundaries. In today's video, we are going to cover the topic probability from class 12 CBSE Applied Maths curriculum. Before we get into the details of probability, what is the probability that you are going to score more than 85% in your board exams? Very high. Yes, definitely it is very high. It is more than 90% if you are consistent with your practice. Okay, so we understand what is probability. Probability is the likelihood of occurrence of any event. Now this chapter has a weightage of 10 marks in your board exams, and in this video I've tried to cover all the important questions from the CBSE handbook, ML Agarwal, and even the PYQs. So watch the video till the end if you want a comprehensive coverage of the entire topic along with the common mistakes that you can avoid while doing questions related to probability. So let's start with the details of probability. So in this chapter we have 4 subtopics. The first one is probability distribution table, very important. Then we have binomial distribution, Poisson distribution, and then normal distribution. So let's start with the common important keywords that you need to understand for the probability distribution table. So what is a random variable? A random variable is a variable whose value is randomly determined by a random experiment, by the outcomes of a random experiment. What do we mean by a random experiment? For example, tossing a coin, or maybe rolling a dice, or picking up a card from a deck of cards. So all these are random experiments whose output is random. Output is random. So the output is not known in advance. That's why they are called random experiments, but definitely they have a defined output somewhere out of the sample space. So a random variable is a variable whose values are determined by chance, that is outcome of a random experiment. It is a function whose domain is the sample space. So whatever are the possible outcomes, that becomes your sample space. For example, rolling a dice, 1, 2, 3, 4, 5, 6, that becomes your sample space. And whose range is a subset of real numbers. For example, for rolling a dice, if I say x is a random variable, that denotes the output as even or an odd number on rolling a dice. So what is the probability of getting a even number? It is going to be 3 by 6, that is 1 by 2. So the random variable x has a definite value. It can have values 2, 4 or 6, and it can have the probability of this getting an even number is 1 by 2. It can also have the values 1, 3 and 5, that is odd numbers, and the probability is again 1 by 2. So you have a random variable that is denoting some output. You have the values of random variables, that is 1, 3, 5 or 2, 4, 6, and then you have the probabilities of those random variables. There are 2 types of random variables, discrete and continuous. Now discrete random variables, they have countable outcomes. For example, I shared about rolling a dice or even tossing a coin. They have discrete countable outcomes. But when we talk of weight of students in a class or height of students in a class or scores in an examination, then these are continuous random variables. So for the first 3 subtopics, that is probability distribution table, binomial distribution and Poisson distribution, we'll be dealing with discrete random variables, and for normal distribution we have continuous random variables. So let's first have a look at what is probability distribution table. It is a table which has at least 2 columns. The first column is the random variable and what are the possible values that this random variable can hold. And the second column is the probability corresponding to each of the values of the random variable, right? Next thing to note here is the sum of all the probabilities in a probability distribution table is always going to be 1. So let's look at some of the important questions dealing with probability distribution table. The first one is Rajat is playing a game of rolling a die with his friends. According to the game rules, he'll win ₹5 for rolling an even number, and for getting an odd number on the die, he loses ₹2. If x represents the amount of money Rajat wins or loses, show that x is a random variable and also represent it as a function on the sample space. Now he wins ₹5 on getting an even number and loses ₹2 on getting an odd number. x is a random variable. First thing is that you need to show that x is a random variable. It represents the amount of money he either wins or loses. So what are the possible values of the sample space? Let's first look at the sample space. What is the sample space here? Because he is rolling a dice, so the sample space can be 1, 2, 3, 4, 5 and 6. Any of these numbers can be the output, right? Now there, x is the function, x is a random variable whose value is decided based upon the outcome of a random experiment, that is rolling of a die. So the outcome of the experiments are random. As the outcome, you need to write this as the outcome of the experiment could be any of these from the sample space, that is random. Therefore x is a random variable, because the question says show that x is a random variable. So therefore x is a random variable. You have to write all this. As the outcome of the experiment are random values from the sample space. So it can be any value out of the sample space, that's why it is a random variable. Now represent it as a function on the sample space of the gameplay. So what is the sample space here? 1, 2, 3, 4, 5 and 6. And what are the possible outcomes? So this is the domain of the function. We understand what is a function. We have done that in grade 11. It has a domain, it has a range, and every element in the domain has a unique mapping to the range. So the domain is 1, 2, 3, 4, 5, 6, and if he gets an even number, he wins 5. That means the output is 5 if he gets 2, 4 or 6, and the output is -2 if he gets 1, 3 or 5. So this is the range. So in the domain we have the entire sample space, and in the range we have two numbers that are subset of real numbers. So this shows that every element in the domain is having a unique value in the range. Therefore x represents a random variable, that is a function in the sample space of the gameplay. Fine. Next, a person plays a game of tossing a coin thrice. So it is 3 times. For each head he gets ₹2 for the organizer, and for each tail he has to give ₹1.5 to the organizer. Let x denote the amount gained. So x is representing the amount gained or lost by the person. Show that x is a random variable and exhibit as a function on the sample space. Now again here, what is the sample space? First get into the habit of writing what is the sample space. So the sample space could be HHH, HHT, HTH, tail head head, one head, then HTT, THT, TTH, and last no head, that means all tails. So these are the possible outcomes in the sample space. Now x denotes the amount gained or lost by the person. So you need to find the value of x. What are the possible outcomes, or what are the possible values that this random variable can have? Again you need to just mention, because it is a random experiment which can have any of these outputs, and these outputs are not known well in advance, so you cannot decide what is going to be the outcome. So it is a random experiment with random outcomes, therefore x is a random variable. Now exhibit as a function of the sample space and denote the, okay. So now you have to write the possible outcomes also. You have to write the range of the function. So if you get HHH, he is going to get money from the organizer, that is ₹6. The possible value of x is 6. If it is 2 heads and 1 tail, irrespective of the order, it is 2 heads and 1 tail. So whether it is in any order, it doesn't matter, the output is going to be same. 4 minus 1.5 gives you 2.5. If it is 1 head and 2 tails, so it is 2 minus 1.5 and then again minus 1.5. So it is 2 minus 3, it is going to be -1. And if it is all tail, then it is minus 1.5, minus 1.5, minus 1.5. So it is going to be minus 4.5. Right? So again, x is a function that is mapping the sample space to a subset of real numbers, that is 6, 2.5, minus 1, minus 4.5. So this is the range of the function and this is the domain of the function. Clear? You may not get such questions in your paper, but it is very important to understand the basic concept, because you might get an MCQ based on any of these concepts, so you should understand the basics first. Next question, 2 dice are rolled simultaneously. Find the probability distribution of sum of digits on the 2 dice. Now here the sum of digits is already shown in this grid, as you can see. 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5. So likewise the grid is already filled with the sum of possible values. So these are all the possible values. So that means a random variable x can hold any of these possible values from this sample space that has been created here. So in this table the values of x are already listed from 2 till 12. Now the probability distribution, we need to find the probability distribution. So the next column in this table has to be the probability of occurrence of each of these values of the random variables. So what is the probability of getting a 2? There is just one possible outcome. So it is 1 out of 36. What is the probability of getting a 3? There are 2 possible outcomes. So it is 2 by 36. So the answer is 1 by 18. Probability of getting a 4. 1, 2, 3. 3 possible outcomes. 3 by 36. So the probability is 1 by 12. For 5, the possible outcomes are 4. 4 by 36. So this reduces to 1 by 9. For 6, 1, 2, 3, 4, 5. So it is 5 by 36. For 7, 1, 2, 3, 4, 5, 6. It is 6 by 36 and it reduces to 1 by 6. For 8, it is 5 by 36. For 9, 4 by 36 and this again reduces to 1 by 9. For 10, just 3 favorable outcomes, so it is 3 by 36 and that becomes 1 by 12. For 11, there are 2 possible outcomes, 2 by 36 and that reduces to 1 by 18. And for 12, it is 1 by 36. So this is your complete probability distribution table for the random variable x. That is denoting the sum of values that you get on rolling 2 dice. Okay, so let's move to the next question. Let x be a random variable which assumes values x1, x2, x3, x4 such that some condition is given to you. Find the probability distribution of x. Probability distribution, again it means it has to be a table in the form of 2 columns. The first column is the values of the random variables and then the probabilities of each of these values. So let this expression be equal to k. Now what is the probability of x1 here? It becomes k upon 2. Probability of x2, it will be k by 3. It is 3 here. So k by 3. Probability of x3 is going to be just k. Probability of x4, k by 5. Right? So first let's write the possible values of the random variable x, x1, x2, x3 and x4. And now we need to find the probability of each of these values. As we understand that the sum of all these probabilities is 1. So that means if we add all of them, k by 2 plus k by 3 plus k by 5 is equal to 1. Take k common out. So it is k here and the LCM is going to be 30. 2 into 15, 310 plus 30 plus 6 equals 1. If you add all of them, 30, 40, 50, 61. So k comes out to be 30 by 61. So the value of k is here. Now we need to find the probability of x1, x2, x3 and x4. So x1 is k by 2. That means half of 30 by 61 and this comes out to be 15 by 61. Probability of x2 is k by 3. That means 1 by 3 of 30 by 61 this becomes 10 by 61. x3 is just k, so it is directly 30 by 61, and x4 is k by 5, so that means 1 by 5 into 30 by 61, that becomes 6 by 61. Now the sum of these probabilities is, see, 30, 40, 50, 61, 61 by 61, that makes it 1. So the sum of the probabilities is all 1 here. Next, let's come to the next question. Now let x denote the number of hours a class 12 student studies during a randomly selected school day. The probability that x can take the values xi for an unknown constant k is given to you. Find the value of k. So we need to find the value of k. So the first step is, let's prepare the probability distribution table. So what are the possible values of x? It can have 0, 1, 2, 3 and 4. So let's fill those values 0, 1, 2, 3 and 4. Now what are the probabilities? For 0, the value is probability is 0.1. For 1, the probability is, if this is 1, then x is 1, it becomes only k. For 2, it becomes 2k. For 3, 5 minus 3 is 2, so it is 2k. And for x as 4, it is 5 minus 4, that is 1, so it is k. So what is the sum of all these probabilities? It is going to be 0.1 plus 2 to 4, 5 and 1, 6, 6k. Now as we understand that the sum of the probabilities is 1, that means 0.1 plus 6k equals 1. So 6k will be 1 minus 0.1, that is 0.9, and then k is equal to 0.9 by 6. Now you can use it as a decimal number also, or you can use it as a fraction also. So if I reduce this to a fraction, it becomes 9 by 60, and this is 3 by 20. So you can use it in either ways, either as fraction or decimal, that doesn't matter. So this was the first part where you need to find the value of k. The second part says, determine the probability that the student studied for at least 2 hours. At least 2 hours means what? Probability of x having a value at least 2 hours greater than or equal to 2. So that is probability of 2 plus probability of 3 plus probability of 4. So that means if you pick up all these values 2, 3 and 4, 2 plus 2 is 4, 4 and 1, 5. So it is going to be 5k. So the sum of the probabilities is 5k. So that means it is 5 into 3 by 20, 5 4s are 20, so it is 3 by 4. You can leave it as a fraction, don't worry. The third part is, what is the third part? Determine the probability that the student studied for exactly 2 hours. Now when it is asking about exactly 2 hours, probability of x equals 2, and x equals 2 means it is 2k. So if it is 2k, that means 2 into what is the value of k? 3 by 20, that means 3 by 10. So this is your answer. And the last part says, find the probability that he studied for at most 2 hours. At most 2 hours means what? Probability of x being less than or equal to 2. At most 2, right? So it is probability of 0, probability of 1 and probability of 2 all put together. Probability of 0 is 0.1. For 1 and 2, it is 2k plus k, that becomes 3k. So let's solve this. 0.1 plus 3k. So it is 3 into 3 by 20, it becomes 9 by 20. So it is 1 by 10 plus 9 by 20, and that becomes 11 by 20. So this is the probability for less than or equal to 2 hours. Easy? Great. So let's move to the next subtopic here. Now what do we have? We have understood, we have seen how to create the probability distribution table and find the values of these constants if something is missing. Now why are we creating these probability distribution tables? So that we understand the average probability of any event occurring. So to understand the average, the question might ask you to find the expectation or the mean of this probability distribution table. And how do we find that average? By just finding the sum of the column that shows the product of probability and the value of the random variable. So far we have created columns where we had two columns, x and probability of x. The third column now gets added is the product of these two columns, and the sum of that third column is going to give you the expectation or the mean or the average of that probability distribution table. Now, because mean is not the correct, or I'll say the only measure for any kind of distribution. For example, you have data points like this. Where is the mean? The mean might be somewhere here in the center. And if you have a distribution where all the data points are around the same point, so the mean is again here. But mean does not tell you how scattered the data is. Here it is more scattered. Here it is very close to the mean. So that's why we have another measure of this probability distribution table, that is called variance. So variance actually takes into account the deviation of each of these data points from the mean. So we have xi minus mu. Mu is the mean. So deviations of all these data points, irrespective of the direction, whether it is in the negative direction or positive direction from the mean. Now, because we have direction also, so that's why we use square of these deviations and then multiply by the probability. So this is called variance. So how you learn the formula? First find the deviations from the mean, square them, and then multiply by probability. So that is called variance. The shortcut is you create column for pi xi square and then square of the mean you take away. You can use this formula also to find the variance, and the square root of variance is called standard deviation. So whatever value you get here for variance, you just find the square root of that value and you get the standard deviation. Okay, let's come to some questions. So the question is, a coin is tossed twice and the outcomes are reported. Prepare the probability distribution table, means x and px, for the random variable x representing the number of heads. So what is x representing? Number of heads. If it is given in the question what is x representing, it's fine. Otherwise you need to mention it in your answer, what is x and what it is representing. Also calculate the mathematical expectation. Now what are the outcomes in the sample space here? Because the coin is tossed twice, the outcomes of the sample space will be TT, HT, TH and HH. Now this is the sample space. So as per this sample space, because x is representing number of heads, so number of heads could be 0, 1 or 2. So we have the values of the random variable now. Now let's find the probability of each of these values. Probability of getting no head is 1 out of total 4 data points in the sample space. So the probability is 1 by 4. Probability of getting one head is 1 by 4 plus 1 by 4, it becomes 1 by 2. Probability of getting 2 heads, it is again 1 out of the 4 points in the sample space, so it is 1 by 4. Now we also need to find the mathematical expectation. So that means you multiply the corresponding x values with the probabilities and create a new column pi xi. 0 into 1 by 4 is 0, 1 into 1 by 2 is 1 by 2, 2 into 1 by 4 is again 1 by 2. As you can again see, the sum of this column is also coming out 1 here. So it says calculate the mathematical expectation. Mathematical expectation is just the sum of pi xi. So here half plus half, it is 1. So this is the mathematical expectation represented by mu. Easy? Great. So let's move to the next question. In a manufacturing unit inspection from a lot of 20 baskets, which includes 6 defectives, a sample of 2 baskets is drawn at random without replacement. Now here the keyword is without replacement. Prepare the probability distribution. So prepare the probability distribution of the number of defective baskets. Also calculate EX. EX means expectation or the mean for the random variable X. So you need to prepare the probability distribution of number of defective baskets. So what is the sample space here? Either you get no defective basket, one defective basket, or two, because you are picking up two baskets. So at most there can be two defective baskets. So what would be the values of the random variable? When there is no defective basket, that means the value of this random variable is going to be 0. Here it is 1, here it is 2. Now what is the probability of getting no defective basket? How do we find this probability? Out of 20 baskets, 14 are non-defective and 6 are defective. So what is the probability that you pick up a basket and that comes out to be non-defective? That means you have picked it up from this lot. So it is going to be 14C2 out of the total sample space is what? 20C2. So you can just calculate 20C2 and keep it aside. What is 20C2? It is 20 factorial upon 2 factorial into 20 minus 2 is 18 factorial. So the value of this is 20 into 19 upon 2, and that comes out to be 190. So you can keep it aside. Now what is 14C2? 14 into 13 upon 2. 14 into 13 upon 2. So this will be 14 into 13 upon 2, and the sample space has 190 elements. So it is 190. So if you calculate this, this comes out to be 91 upon 100 in the lowest form. Now what is the probability of one defective basket? 1. One defective basket, that means one is non-defective and the other is defective. Or it could be that the first one was defective and the second one was non-defective. It could be any of these two combinations. So how do we find the probability of one defective and one non-defective basket is 1. So you are choosing 14C1 and 6C1. One from the defective lot, one from the non-defective lot, right? And then divided by the sample space, that is 190. Now this is to be repeated 2 times because there are 2 possibilities, that first non-defective then defective, or first defective then non-defective. So you will multiply this by 2 also. So let's calculate 2 into 14C1 is 14, 6C1 is 6 upon 190. And if you reduce this to lowest form, it comes out to be 42 by 95. So this is the probability. Now what is the probability of getting 2 defective baskets? 2 defective means both are selected from this 6, count of 6. So it is 16C2 upon 190. 6C2, sorry, not 16, it is 6. 6C2 upon 190. What is 6C2? 6 into 5 upon 2 into 190. And if you calculate this and reduce to lowest form, it comes out to be 3 by 38. So now we have the probabilities of 0, 1 and 2, all the values of the random variables. So let's find Pi xi because we need to calculate the expectation. So here it is 0, 1 into 42 by 95 is 42 by 95, 2 into 3 by 38 is, it is going to be 3 by 19. So now what is the expectation? The sum of this column. So just add these two values, 42 by 95 plus 3 by 19. So 95 is fifth multiple of 19, 5 3s are 15, 15 plus 42. So it is going to be 57 by 95. Is this in lowest form? Always make sure that the answer should be in the lowest form. So it is, yes, you can leave it here or you can even convert it to a decimal number. So the mean expectation or the expectation, because the question says calculate Ex, write it in terms of Ex only. So Ex is 57 by 95. Always highlight your answer. So this is the expectation for the random variable X. Clear? Okay, so let's move to the next question. Let X denote the number of hours a person watches TV during a randomly selected day. The probability that X takes the values x where k is an unknown constant are given to you, find the value of k. So this question is similar to one of the questions we have already done. So let's put the values of the random variable 0, 1, 2 and 3. So it is 0, 1, 2 and 3. Yes, these are the possible values. So if it is 0, it is 0.2. If it is 1, x is 1, it becomes 1k. If it is 2, then it is 2k. And if it is 3, it is 5 minus 3, that becomes 2k. So these are the possible values. What are the sum of these values? 0.2 plus 5k. So as we understand, the sum of all the probabilities should always be 1. That means 0.2 plus 5k is 1. So that means 5k is 1 minus 0.2, that is 0.8. So k is going to be 0.8 upon 5. You can take it as a fraction or a decimal. 5 ones are 5, 30, 5 6 are 30, 0.16. So value of k comes out to be 0.16. So the first part was find the value of k. The second part is what is the probability that the person watches 2 hours of television on a selected day. So it is exactly 2 hours. So that means you need to find probability of 2. Probability of 2. This is the second part of the question. So this is going to be 2k. That means 2 into 0.16. That comes out to be 0.32. Third part. What is the probability that the person watches at least 2 hours of television on a selected day? At least 2 hours means what? At least 2 hours means x has to be greater than or equal to 2. So that means probability of watching it for 2 hours, for 3 hours together. So 2 and 3, if you look at it, 2 plus 2 is 4k. So this is equal to 4k. That means 4 into 0.16. It comes out to be 0.64. Next part. Fourth part is what is the probability that the person watches at most 2 hours of television? So at most 2 hours means what? X less than or equal to 2. So that means probability of 0 plus probability of 1 plus probability of 2. So probability of 0 is 0.2 plus probability of 1 is k and 2 is 2k. 2k plus k becomes 3k. So 0.2 plus 3k, that means 0.2 plus 3 into 0.16. So this is 0.2 plus and that comes out to be 0.68. Easy? Now what is the next part? Calculate the mathematical expectation. To find the mathematical expectation, we need to add another column for pi xi, the product of these two columns. So let's find that. What is the product? 0, here it is k, here it is 4k, and here it is 6k. So what is the sum? 11k. Let's put the value of k and find the mean expectation. So we need to find the mean expectation. We can denote it by ex or by mu. It is the same thing. So that comes out to be 11k. That means 11 into 0.16. So it is going to be 176 and 1.76. So the mean expectation is 1.76, and now we need to find the variance and standard deviation of the random variable x. So for variance and standard deviation, we need to add another column here, that is pi xi square. So to find the value of this, we can multiply pi xi by xi again. So if you multiply these two columns, you get pi xi square. So it is 0 here, 1 into k is k, 2 into 4k is 8k, and 6 3s is 18k. So what is the sum of this column? Let's find out first. 27k. What is the formula for variance? Variance is sum of pi xi square minus sum of pi xi whole square. Always write the formula. Don't be in a hurry to just solve it. Always write the formula. So what is the sum of pi xi square? It is 27k. Minus pi xi is 11k. So that means square 11k whole square. So let's calculate all these values now. 27 into 0.16 minus 11k we have already calculated, that is 1.76. So we can directly write this value here. 1.76 whole square. So what is 27 into 0.16? So it will come out to be 4.32 minus square of 1.76. What is square of 1.76? It is 3.0976, and after subtracting, the variance comes out to be 1.22. Clear? Do we need to find standard deviation? Yes, we need to find standard deviation also in the next part. So that means we need square root of 1.22. I hope everyone understands how to find square roots of numbers. So the standard deviation is square root of 1.22, which will come out to be 1.1. So this is the standard deviation. So we have the mean here, variance here, standard deviation here. Highlight all your answers in boxes so that it's easier to locate them. Okay, so let's move to the next question. In a game, a man wins ₹5 for getting a number greater than 4 and loses ₹1 otherwise when a fair die is thrown. So you have the sample space. What is the sample space? Let's look at it. The man decided to throw a dice thrice. So he's throwing it thrice, but to quit as and when he gets a number greater than 4. So if you get a number greater than 4 in the first throw, you quit. If you get a number greater than 4 in the second throw, you quit. If you get a number greater than 4 in the third throw, you quit. Otherwise also, because you have done all the 3 throws, you quit after 3 throws. So what is the sample space? Let's first understand. So getting a number greater than 4 means winning the game, suppose. Getting a number less than 4 is losing. So what is the probability of winning? What is the probability of winning? What is the sample space here? Sample space is because he is throwing it how many times? Throw a dice thrice. So he is throwing the dice 3 times. So what is the probability of getting a number? What are the outcomes when you throw a dice? 1, 2, 3, 4, 5 and 6. So if he wins in the first go, that means what is the probability of getting a number greater than 4? It is favorable outcomes are 5 and 6. So it is probability of getting a number greater than 4 is 2 out of 6, which is 1/3. Probability of not getting a number greater than 4 is probability of getting a number less than 4. So less than 4, the probability is going to be 4 out of 6, which is 2/3. Fine. So these are the probabilities of winning, or you represent this as losing. So if he gets a number greater than 4 in the first throw, that means he wins in the first throw. The probability of getting this is 1/3. So that means he is going to win ₹5. So the value of the amount he is going to win is ₹5 if he wins in the first throw. Suppose he loses in the first throw and then wins in the second throw. So that means for the first throw, the probability is 2/3, and for the second it is again 1/3. So the total probability, let's focus on the money first. So that means he loses ₹1, so it is -1 plus 5, so he is going to get ₹4. Next, if he loses in the first throw, if he loses again in the second throw and then gets a number more than 4 in the third throw, so that means how much he is going to get? -1 plus 5, and that will be 3. This is the value of the random variable. Otherwise, he is anyways quitting after 3 throws. So it's quite possible in all the 3 throws he doesn't get a number greater than 4. So he's losing again and again all the 3 times, and then he quits because he doesn't want to lose more money. So the output is -3. So these are the possible values of the random variable. Now let's find the probability of each of these random variables. If he wins in the first throw, that means the value of the random variable is 5. What is the probability of winning? It is 1 by 3. So the probability here will be 1 by 3. If he loses and then wins, that means 2 by 3 into 1 by 3. The probability is 2 by 9. If he loses 2 times and then he wins, that means 2 by 3 into 2 by 3 into 1 by 3. The overall probability becomes 4 by 27. And if he loses in all the 3 throws, he doesn't get a number greater than 4. So it is going to be 2 by 3 into 2 by 3 into 2 by 3, 8 by 27. So we have the probability distribution table now in place. We have the possible values that this random variable can have and the probabilities. Now what do we need to find? We need to find the expected value. Expected value means mean. Expected value of the amount he wins or loses. So how do we find? 5 into 1 by 3 becomes 5 by 3. 4 into 2 by 9, 4 to the 8, 8 by 9. 4 3 is 12, 12 by 27. 8 3 is 24, 24 by 27. So the mean is the sum of all these values. So let's add all of them together. So the LCM is 27, 27, 3, 9 3s are 27, 8 3s are 24. So let's put them together. So it is 27 and we have 3 9s are 27. So 5 9s are 45 plus 8 3s are 24 plus 12 plus 24 and then you add all of them. (105 by 27). Now these have common factors, so when you reduce it to lowest form, it comes out to be 3 3s are 9, 3 5s are 15 and 3 9s are 27. So it comes out to be 35 by 9. Okay, you need to take care of this minus here. It was minus, so this term is minus, so it should be minus 24 here. Minus 24, that means it is not 105, so it is going to be 24, 24 gets moved out, 67 by 27, 57, 57 by 27, and when you reduce it to lowest form, it is going to be 19 by 9. So that means on an average, he is going to win 19 by 9 rupees. So this is the mean expectation, right? So I hope you understood this question. So the first thing is focus on the sample space. What are the possible outcomes? What is the random variable representing amount he wins or loses? So focus on the amount. There are 3 trials and you have to find the amount he wins or loses in each of these trials. Three times he is throwing the dice. So once you have the amount, find the probability of winning that amount or losing that amount, and then find the product of Pi, Xi, and then calculate the mean. Okay, so let's move to the next question. The random variable X can take only values 0, 1, 2 and 3. You are given probability of 0 and 1 is P and 2 and 3. Okay, they are equal such that some condition is given. So let's first find the probability distribution table. So the values are 0, 1, 2 and 3. P of x0 is P. So let's write as P. 1 is also P. So let's assume for 2 and 3 it is equal to K. Let's take another constant. So it is K here and this is K here because both are equal. So let's find Pi xi. It is 0, P, 2K and this is 3K. So according to the question, this is the condition given to you, pi xi square is equal to sum of pi xi. So let's find the next column, that is pi xi square, multiply pi xi by x value, 0 into 0 is 0, 1 into p is p, 2 into 2 is 4k, and then 3 into 3 is 9k. So as per the question, let's find the sum first. 14k, and this is, it is 13k plus p, and the sum of this column is 5k plus p. So as per the question, sum of pi xi square, that means the sum of this column 13k plus p is equal to 2 times pi xi. So it is 2 times 5k plus p. And we need to find the value of p. So let's try to eliminate k somehow. We also know that the sum of all the probabilities is always 1. So that means 2p plus 2k is always 1. So let's use these two equations and find the value of p. We need to eliminate k somehow. So if I take this 2 to the other side, p plus k is half and k is half minus p. This is 13k plus p equals 10k plus 2p. 13 minus 10 is 3k equals 2p minus p becomes p. And in place of k we can put half minus p, because we need to eliminate k, we need to find the value of p. So focus on p. So eliminate this k. So this becomes 3 into half minus p equals p. Let's solve this. It is 3 by 2 minus 3p is equal to p. That means 4p is equal to 3 by 2, and the value of p comes out to be 3 by 8. Understood? So always remember the sum of all the probabilities is 1. So you get one equation from here and second from the condition that is given to you in the question. Just keep on calculating the columns, writing the columns, adding the values of the columns, and then you get the value of p. Okay, so let's move to the last question. Two numbers are selected at random without replacement. Now again, without replacement is important. Whenever it is without replacement, how do you handle that? From the first 6 positive integers, let x denote the larger of the two numbers obtained. So x is larger of the two numbers obtained. Calculate the mathematical expectation of x. So what is the sample space here? So the numbers are selected from the first 6 positive integers. So first understand that. What are the first 6 positive integers? 1, 2, 3, 4, 5 and 6. It is as good as rolling a dice. So two numbers are selected. That means you pick up any two pairs of numbers and you have to find pairs where the second number is larger. X denote the larger of the two numbers. So if you have, let's look at the sample space. If you have a combination of 1, 2, which is the larger of the two? 2 is larger. So 1 can never be larger than, because 1 is smallest. So you can never have a value of 1 for the random variable. So that means out of this combination 2 is larger. So 2 is the only possibility here. So for 2 being larger, do we have any other option for the first number? No. 1 is the only option. 1 is the only number less than 2. So suppose 3 is the larger of the two numbers, then the possibilities will be 1, 3. You get 1 in the first pickup and then you get 3. Or you can even have 2, 3. If the first number is 3 or bigger, then it doesn't come into this category. So 3 is the larger of the two numbers. 3 is larger, 3 is larger. So the possibilities are 1, 3 and 2, 3. To have 4 here, 4 is the larger of the numbers. Then it can be 1, 4, or maybe you got 2 first and then 4, or maybe you got 3 first and then 4. Then the next random variable could be 5. That means 5 is the larger of the two numbers that you have chosen. So it could be first you chose 5 and then 1 and then 5, or 2 and then 5, or 3 and then 5, or maybe 4 and then 5. And 6 could be the larger of the two numbers that are chosen. So that means the sample space could be 1 and then 6, 2 and then 6, 3 and then 6, 4 and then 6, and the last possibility could be 5 and then 6. So this is your sample space. So focus on the sample space first, and accordingly keep on writing the values of the random variable. So it is denoting the larger of the two numbers, so I have written only the larger of the two numbers out of all these combinations of the sample space. Calculate the mathematical expectation. So first we need to find the probabilities of each of these events. How many total events are these? 1, 2, 3, 4, 5, 9, 12, 14, 12, 15. So total number of events is 15. So what is the probability of getting 2 as a larger number? It is just one event out of total 15. So the probability here is 1 by 15. Here it is 2 favorable outcomes out of 15. So it is 2 by 15. Here you have 3 favorable outcomes out of 15. So it is 3 by 15. Here you have 4 by 15, and lastly you have 5 favorable outcomes out of 15. So these are the probabilities of each of these random variables. Now because we want mathematical expectation, so let's find the product of pi xi. So it becomes 2 by 15. Let the denominator be 15, it's easier to calculate. 3 2s are 6, 6 by 15. Then 4 3s are 12, 12 by 15. Next is 5 4s are 20, 20 by 15. 5 6 are 30, it is 30 by 15. So let's add all of them because we need the mathematical expectation, that is sum of pi xi. So let's add all of them. It comes out to be 70 by 15. And if you reduce it to lowest form, it will be 14 by 3. Right? So this is the mathematical expectation. It can be denoted by mu or ex, that's the same. So it is 14 by 3 for getting a number larger than 4. Clear? Is this question clear? Great. So let's look at some of the important points to avoid common mistakes when you are handling questions related to probability distribution table. So the first thing is very important, always understand the sample space first. Write what the random variable is denoting. If it is not given in the question what is the random variable x, then please mention what is x and find out the possible values of this random variable. After this, find the probability of each of these values of the random variable to get the probability distribution table. So once you are done with the probability distribution table, most of the work is done. So if the question asked you only for the probability distribution table, then that means you just reduce all the probabilities to lowest form and leave it there. That's it. But the probabilities should be in the lowest form. And if you need to further find the expectation or the variance or standard deviation, then you may leave the probabilities with the same denominator so that your calculations become easier. Do not reduce to lowest form in the distribution table because you need to find the expectation and variance also. So let it be. Denominators will help you, same denominators. Keep a check that the sum of the probabilities is 1. So always the sum of the probability table, probability column in the probability distribution table is always 1. So keep a check on that so that you don't have made any mistake while you were calculating the probabilities. The sum of all the values should be 1 always. Now use the correct formula for expectation, mean or variance as it is needed, and the answer should be in either decimal or fraction, it doesn't matter. So it doesn't matter whether your answer is in fraction or decimal, just that the answer should be in lowest form if it is a fraction, otherwise you can convert it to a decimal number. So use the correct formula and find your answer. Now here we have a comprehensive list of all the formulas related to probability. If you want a complete formula deck for all the formulas of your entire CBSE syllabus for class 12 applied maths, you can visit my website, that is www.boundlessmaths.com/class12am. So you can get your copy of the formula deck where you have all the formulas of your entire syllabus comprehensively captured in a few sheets. So that will help you to revise your entire syllabus faster and to retain all those formulas, right? So if you like the video, if you found the video useful, don't forget to hit the like button, share the video with your friends so that they also benefit out of it. Subscribe to Boundless Maths if not done so far. Hope you like the video. Keep watching. Keep learning. See you in the next video.